Okay, so we've got Greg speaking with us today on Zoom, KJ6ER, and several months ago, someone sent me a tip on Greg's presentation, and he said this guy's really good, and so and I've heard it from different people, so um, you can't go wrong there, I guess. But it took a few months to get him in a slot here. So Greg, thank you so much for joining us, and man, if anybody wants to learn about vertical antennas, this is the guy. So take it away, Greg, and thank you for being here tonight.
Well, first of all, I'd like to thank, is that Rob talking? I can't tell.
That is Rob, yes.
Yeah, thank you, Rob, for the invitation. I really appreciate it. And it's great to be with you all. I assume I can start sharing, so let's get right to it.
Sure.
Oh, before I do, I'm good until what, 8:30? Is that good, or do I need to stop earlier? You tell me.
8:30 is about right. Yeah, your thumbs
Okay.
up, no problem.
Okay, you let me know if and I'm happy to answer questions as I go along, or I can save them to the end. Either way you'd like to do it, it's fine with me. And congratulations on the new hams. I love to see that. And the ones that are getting ready to take some more exams, good luck tomorrow. I'm sure you'll do well, or as best as you can. All right, so let me start the sharing process. There we go. And I'm going to ask that inevitable question. Can you see my slide?
Yeah, we got it.
All right, excellent. All right,
Yes,
now
we
let me just
can.
adjust things on my end so I can. There we go. Okay. All right. Well, greetings. Let me go to the first page. First of all, I am Greg Miron. Everyone pronounces it wrong, but that's okay. I'm kind of used to that. I was born in the upstate New York. I got my electrical engineering degree at Case in Cleveland, Ohio. And you know, my first job was right there on Page Mill Road, sitting just 50 feet away from Bill and Dave. I remember seeing Dave Packard get up when he was in town and literally walk from department to department, management by wandering around. I was 22 at the time. I really didn't appreciate how significant that legend was at the time. But looking back on it, I was blessed to have that experience. It was just amazing. He'd even stop by my desk every month or so and ask how HB was treating new college hires. And of course, I'd be petrified that I'd say the wrong thing, but I always tried to say the right thing. But I did work in several big companies and quite a few startups, HP, Cisco, Flex, and really had a good time. I didn't want to retire because I was having too much fun. But then a lot of things convinced me to do it, including grandkids. We've got 5 grown kids spread around the country, 6.5 grandchildren now, I just found out. So we're excited about that. I live all the way down here in Campbell, California. Oh my goodness. Most of the time, these presentations are to Europe and all over the US, Canada, even a couple in Mexico. So this is a relatively local one, so it's always fun to do that. Um, I love to play golf. I'm not very good, but I'm a bogey golfer and I have fun. And it's a classic retirement hobby and activity. So my youngest son got me into it, and so I do that when I'm not ham radioing. But I also love to hike, especially there in the Palo Alto foothills and down here in the South San Jose foothills. It's just gorgeous. I take my ICOM 705 backpack, do some QRP. I really love to do that. We'll talk a little bit about that. I do a lot of music. Yeah, I'm one of those garage rockers. Ever since I was a kid, still play, still record, still perform, but smaller and smaller audiences. But by all means, though, more than anything else, I am a geek, and I'm proud to be a geek. In particular, I'm a POTA geek. I've done over 1,000 activations all over the Bay Area since I think it was January of 2021 when I did my first activation. I did pass my extra class license in the 90s right there in Palo Alto. Had to go through 20 words per minute, and that was probably the last time I did 20 words per minute. I hate to say that, but now that we're approaching the solar minimum in 2030, 2031, I need to get my proficiency back up because we all know CW, other than digital, is the most efficient platform. So, and we know it's going to be tough to be heard around the world in 2030 and 2031, but then it's going to go back up again. But anyway, that's me, and that's where I am. Uh, you can take notes if you're interested in this sort of thing, but everything I'm talking about, including All of these slides, they're a subset of my antenna primers. All my antenna friends, I always like to say that when it comes to the economy, I'm a capitalist, but when it comes to ham radio, I'm a socialist. I give everything away. I believe it's important to share the knowledge and the wisdom for the greater good of the collective community. So let's get it up there. And so I design all these really nifty portable antennas, and I share them in 18 to 20 page PDFs full of my computer model graphics, parts, where to buy the parts, how to build, tips and tricks, SWR sweeps in the field at all local Bay Area parks. So everything is on my website, free antenna plans. As I said, all my primers, I've written a couple of antenna primers, and they seem to be really popular, get a lot of downloads with those. I also have a monthly newsletter, and it doesn't go through paper. So I'm not going to run out of paper at the printer. I believe in email. So I've got what I call an Antenna Geeks email list. If you're interested in this kind of stuff, or you just want to learn about antennas and other ham radio related topics, I put those out every month. And the next one's coming out probably in a couple of weeks. We're going down to San Diego to see a couple of our grand critters here next week, but probably when I get back, I'll put that together. You can see all the other previous newsletters that are on there. So by all means, if you're interested in this sort of thing, just go to my my website, which is my call sign, kj6er.net. And I'm really I love interacting with other hams. So my email, greg@kj6er.net. If you have any questions you don't want to ask tonight, or if you wake up at 2 in the morning because of that cortisol shot and you're thinking about antennas, heaven forbid, and you think of a question, just send me an email. I get about 24 emails overnight, and the next morning I sit down with my 2 cups of Italian roast coffee and I answer them all the next day because I believe that's important. I love to do that, and I love to interact with you all. So no question is too big or too little. By all means, just send me an email if you feel so motivated. Again, everything is on kj6er.net. It is always free, always free. All right. Well, one of the things that really kind of helped some of the visibility of the things I'm going to talk about tonight was, and I give thumbs up to our ARRL youth leader out there in the East Bay. Thank you for attending the meeting tonight. I think it was about a year and a half ago, QST magazine had an antenna competition, the 2024 antenna competition. And I wasn't even aware of it, tell you the truth. Then a couple of my buddies prodded me to submit one of my antennas, the Performer antenna, portable elevated resonant. We'll talk about that in just a moment. And 3 days before the deadline, because I just found out about it, I submitted my computer model because they wanted to make sure it was real science, not that fake stuff. They also wanted to write up and how I felt about the antenna, how I use it, and such. And so I submitted all that, and lo and behold, about 3-4 months later, I think they wrote me an email in May and let me know that I won second place. And I was really honored by that. I've been an ARR member since probably the late 80s when I first got my novice license, because in those days there was a novice license. I went from novice to general to advanced to extra in the early 90s. And so I won second place, and I was really happy about that because I did not expect it. And along with winning that in the September QST magazine, they took my PDF and worked with me to compose a 5-page article on this antenna, the Performer, which I'll talk about a little bit tonight. And so now I can take this off my bucket list. I got an article in QST. Woohoo! I love that. I was very proud of that. Very honored to have achieved that award. And I didn't even know this. I guess I didn't pay attention to it, but in every QST, you can vote for your favorite article. And lo and behold, the Performer article won the Cover Plaque Award, and that was presented to me by the section manager. And it's now hanging proudly on my ham shack wall upstairs in my little ham shack here in Campbell, California. So I'm really proud of that. And I just love working with the ARRL. In fact, one of my newsletters about 3 months ago was all about how to operate successfully during the impending solar minimum coming up in 2030, 2031. And it caught the eye of Becky, who's the editor, and she wanted me to put together an article. So that's going to come out next year in QST. about how to operate successfully during the solar minimum. So that was a lot of fun. I basically took what I had in my newsletter write-up, which was about a 15-page PDF, and I condensed it down to their perfect 1,800 words, which is about 4 or 5 pages. So I'm, again, going to appear in QST. So I'm really happy about that. All right, so what do I do and why am I here, right? Well, it all started back in 2020. I was still working, and I wanted to get into parks on the air. I work out of my ham shack, but only about maybe 10 to 15% of my total QSOs are from my ham shack here at home, because like many of you, the neighborhood is very, very noisy. And I got anywhere from an S4 to an S7 or 8 sometimes, depending on the band and the time of day. But I always loved being outside. And so then this whole thing of Parks on the Air started, POTA. And I thought, wow, this is way cool. I've got to get into this because I love the whole idea of taking my my ICOM 7300 to a picnic table, which I did at the time. And then I picked up an ICOM 705 QRP radio, which I love to have in their backpack. But I didn't have an antenna, so I started talking to folks who had a lot more experience than me at portable activations, and they all kept pointing me to just go to HRO. There's a lot of cool antennas there, et cetera, et cetera. And I started looking at these commercial antennas, and I said, 400, 500, $650? No, 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 no. I'm not going to do that. So being the geek that I am, and yes, I was still working at the time for Flex, actually in San Jose, during my lunch hour, and maybe a little bit around the lunch hour, I started doing some research and I started reading about some very brilliant antenna scientists who really motivated me to get into computer modeling. And I started doing some computer modeling because I wanted to design an antenna for myself. And I didn't want to just guess at what the antenna should be. Being an engineer, being a geek, I wanted to understand what kind of antenna would perform best. And so then I learned about radiation efficiency, and we'll talk about that a lot tonight because that's my top priority. So hang on 1 second, we'll talk about that. So I designed this antenna. It ultimately became the Performer. But what happened is I didn't have a name on it. I just said it was an elevated quarter wave with 2 elevated radials. And I tested it quite a bit in my backyard before I took it to POTA Parks. And I kept getting hunters, Parks on the Air hunters, people who contact you are called hunters. Hunters kept saying, "You're the loudest signal on the band. How much power are you running?" And I said, "I'm just running in 100 watts on my ICOM 7300. And they go, "Wow, you're so loud. I can barely hear anyone else, but I can hear you." And then I realized, you know what? It's probably because I'm radiating over 90% of my power applied to the antenna. That's called radiation efficiency, and we'll talk about that. At that point, I started getting emails from some of these people saying, could you share that design with me? I'd love to build my own version of your antenna. And so I did that, and I set up a little email, and I used to send this email out when people contacted me. And then more and more people began to hear about it, portable activators, especially as POTA became more popular. And I realized I started getting 50 emails over the span of 2 or 3 days, and I said, I better do something different. So I wrote up this, turned out to be an 18-page PDF with computer models and graphics, parts, and where to get the parts, how to set it up in the field, pretty intricate, like something a geeky engineer would put together step by step. And then I thought, after spending years at HP, Cisco, and a few startups doing some marketing kind of strategy and that sort of thing, I said, I'll just throw a name on it. Let's have some fun. This is a hobby after all. So I called it the Performer, portable, elevated, resonant. So we'll talk about that just a moment. And that inspired me. That was so much fun. And I just gave this away. I didn't want to, put it in a book and sell it. I just felt it was important to share it, as I said. So I started looking at other antennas. And so what I love to do now is I go deep inside these thick antenna books that talk about antennas that are primarily written for other RF engineers, to tell you the truth, with all these fancy charts and graphs. And so I take some of these classic antennas and I try to come up with a fresh implementation, a new configuration for portable use. And I try to simplify them as much as possible because I want people to use these. And I also want to get more young people involved in home brewing. building your own antennas, because that's our last frontier, right? Our last frontier in ham radio is building our own antennas. Yeah, you can build some QRP kits. Those are really cool. But for the most part, it's all about antennas. So I'm going to try to encourage you not to go out and buy a portable antenna. I want you to build your own. And that's why I give these plans away for free. So I redesigned these classic antennas. I developed the design, share the free plans. And then like I said, a big part of this, I have to actively interact with these home brewers because they need support. And so I've been a ham since the 90s, and so I'm happy to be a virtual Elmer. Many of them write me on a weekly basis, so it keeps me busy. But I love doing that, and I love sharing the goodwill of ham radio. And some of the coolest emails I get are from guys, let's say in their 80s, who are saying, you know, I just became a ham. I'm 81 years old, and please help me be successful. At the same time, I get emails from 16-year-olds and 15-year-olds. And so I feel it's my obligation to do whatever I can to encourage them and make sure that this becomes a lifetime hobby, because this is an amazing hobby. It has so many amazing people. And as my dad told me when I was young, the best part of ham radio are meeting other hams, like at your club tonight, and like I do at all these ARC presentations I provide now around the world. So I developed these designs. And one of the things that Bill Hewlett taught me back in the late 70s when I first joined HP, to be a good engineer, you've got to have design principles or design objectives, right? Even more important, they have to be measurable. Because if you can't measure them, then how do you know if you're going to be successful, right? We all know that. That's business planning 101. But when it comes to an engineer, we don't think that way. And so he helped us remind us that how important it is to set up very specific design objectives. So in my case, when I think about designing these portable antennas, I think first and foremost about performance, because that's what differentiates one antenna from another, right? You can just put a piece of wire in the tree. Well, you can't put wires in trees in California technically, but you can just throw a wire up in your backyard and put a balun on it and you got yourself a dipole. That's great. But when you talk about portable antennas that have to be taken to parks or backpacked here and there, you want to think about a bunch of other things. And especially when you're going into this impending downturn of the cycle, which we're heading to in 2030, 2031, you want to make sure you're as efficient as possible with your watts. So number one for me, highly efficient and effective antennas in my design. They're all resonant. They're multi-band antennas, but only one band at a time. And the reason they're one band at a time is because I want to preserve not only the radiation efficiency for that particular band, but the radiation pattern. If it's got a low angle of radiation for DX or high angle NVIS, I want to preserve that. So each band performs the same. And it has a more consistent impedance on each band as well. So they're all resonant. You don't need a tuner. I don't want you to include the insertion loss of a tuner in that ham radio circuit. So you don't need a tuner. They're resonant, one band at a time. And most importantly, radiation efficiency 90% or greater. That means if you apply 100 watts at the feed point to your antenna structure, you'll radiate at least 90 watts versus much less than that if you have a different kind of antenna. And we'll talk about that tonight. So you think that's every antenna is 90% efficient. No, most antennas, especially the commercial ones that don't spec this, are probably running 45, 50%, half that. And we'll talk about that. So performance, number one. What's number two? Well, these are portable antennas. And they started out being purely for portable, but then I found a lot of guys live in restricted neighborhoods, HOAs around the country. And so they want to set these things up and take them down after dinner. So fast and simple deployment. In fact, I try on purpose to design these antennas so that they are relatively simple to build. And we'll talk about that. I call these tinker toys. I'll talk about that in just a moment. But I want to make sure that the setup or the takedown time is 5 minutes or less. And now that I've been doing these antennas, I only use my own antennas. I can do them in 2-3 minutes. But most of the people I talk to who set up these antennas and really enjoy using these antennas can do it in 5 minutes or less. I call that elegance. Because think of some of the amazing products that come out of Silicon Valley. They're really simple on the outside, all the complexities on the inside, but you don't have to deal with it. So it's the user interface. That's elegant. fast and simple deployment. And again, because these are portable antennas, I want to make sure they're easy to pack and easy to transport. And they don't take up a lot of space in your garage or in your trunk or wherever you leave them. And then when you have to put them, then when you want to carry them to the portable ops site that you want to work at, I want to make sure they fit in your backpack and don't weigh a lot. I want to make sure that they're easy to bring to the picnic table, or as I mentioned, to deploy to your HOA. So they have to be lightweight. They have to be, because they're simple, I want to make sure they're lightweight, 5 pounds or less. And they all easily make it at 5 pounds or less. Unless you buy one of those big, heavy tripods, that's your choice. I don't use one of those. But that whole thing comes down to convenience. So when I think about it, antenna designs, I think about performance, 90% radiation efficiency. I think about elegance, fast and simple deployment, 5 minutes or less. And I think about convenience, easy to pack, easy to transport. Make sense? Yep. Okay. Keep going. Well, that was about 3 years ago I started doing this, and I'm very proud to say and quite surprised to say that since over the last 2.5 years, I've had 120,000 downloads around the world, of which 1/3 are outside North America. And I tell you, if you give something away for free that people find of value, it spreads pretty quickly around the world, even in the ham radio community. And as I said, I love answering some of these emails from people all over the world. And thank heavens for Google Translate, because I can come back to them in their own language or decipher what they're trying to say in English sometimes. So I'm really proud of that as well. And I'm going to continue to give these away for free. And that number is going to continue to grow, I assume. But what do? Efficient and effective antenna, which I call for the every ham. I don't want to design antennas where you got to be a really smart antenna scientist or RF engineer. I want it to be for the technicians and the generals and even us extras, right? Something that the every ham can deploy if they want to go portable, either for fun or for emergency communications. And a lot of these antennas one in particular that I've designed is used for ECOMs. And I heard one of you mention that tonight. As I mentioned, I focus on performance, elegance, and convenience. So now when I think about an antenna, a new design, and I'll talk about one tonight that I haven't announced yet, but I will be announcing here in the next month or so. And I've been testing quite a bit. I am a geek, as I mentioned. I'm proud of it. I do think of the math and physics behind it. I want to understand to a certain extent what the math and physics are involved with that particular antenna that I may have read about deep inside of an antenna book, but only about 5% of my time, because I'm very pragmatic. I started out in electrical engineering, but moved my way up into business development, strategic marketing, even executive communications. And so I have a right brain and a left brain. So I like the technology, but I also like to understand the big picture as well. So 5% of my time doing the math and physics. Then I discovered computer modeling. Oh my gosh, did I love this. I didn't realize these kind of programs existed. And I started on the hardest one. I don't recommend, if you want to get into computer modeling, I don't recommend you get into this one first. I think there's some easier programs like MMGAL and EasyNet, but I started on the granddaddy of them all that was originally written up in Livermore Labs for NEC2. The reason I love this program, it produces these amazing radiation graphics, 3D radiation graphics, and I put them in all my PDFs when I design an antenna. So we'll be talking about that as well. So that's about 15% of my time. But here on my POTA stamp yard here in Silicon Valley, and I think most of us live on these tiny little lots, except those of you in the Palo Alto Hills, I spent 80% of my time taking the design that I created here in the virtual world to bring it into the real world. And this is my antenna proving ground right there, my backyard in Campbell, California, right next to the solar panels. And that's where I take what I learned here. And wow, are there a lot of adjustments I have to make. I mean, you can emulate ground soil conditions here in the model, but you can't emulate everything the way it is in reality. And you can't emulate near field surroundings and trees and rocks and fences and neighborhood noise and everything else. So I have to take it out here, and I kind of make the design more pragmatic, more realistic. I take a lot of notes. I keep it all on my phone so I can keep it portable. Once I feel 100% of my time in the development is done, We're so lucky we have parks on the air because that's my real world evaluation. Before I introduce an antenna design that I brought through from the physics to the modeling to the backyard proving ground, I put it in real world evaluation in parks on the air. That's why I love parks on the air. I can take wacky antenna designs and I can deploy them in the park and see how they perform. I A/B test a lot of these antennas with hunters all the time. I also take notes on, okay, so what went really well about the deployment? Oh, what is something in the design that I really should fix so it's easier to set up or performs better? So this real world evaluation is important. And I take out every antenna before I share the design at least 6 times, at least a half dozen times. And I go out on POTA activations once or twice a week. POTA is field day every day. Well, I do it twice a week. And I have a bunch of buddies that I visit at some of these parks, typically down here in the South Bay, like South San Jose and that area. There's a lot of great parks down here. But I put them through the real world evaluation. I learn a lot. And then, and only then, do I share the design with friends and I get beta testers. I have beta testers. But once I get their feedback, then I share it in my newsletter and it goes out to my subscribers. And I have several thousand of those. Okay, so we talked about Tinker Toys, right? We all grew up with Tinker Toys. We love Tinker Toys. When I go visit a couple of our grand critters in San Diego next week, I'm going to be playing with some Tinker Toys and Lincoln Logs and all these other newfangled toys that kids have nowadays that we didn't have when we were their age. But I love Tinker Toys because you could basically put them all together, use the same pieces, put them all together, and make different kinds of things. Kind of like an erector set back in the day as well. So this is kind of like my Tinker Toys of antennas. And when I design antennas, I keep in mind I want to make sure that this is stuff that already exists in most people's ham radio stuff box. And I've got 5 or 6 of those boxes, but I don't want to use components that, for the most part, you have to go out and buy special. I want to put together components in an antenna design that you may already have, or they're easy to get at a flea market, and you can use over and over again, even in different antenna designs. So I use the same components in all my designs. I just rearrange them. I reconfigure them to make different types of antennas. Those are Tinker Toys, right? So what do I use? Well, as I mentioned, one of the things I learned early on in POTA is that California parks don't like you putting wires in trees. The rangers don't like that. So I learned that lesson right away. And so I quickly evolved to telescoping whips, and I love 25-foot and 17-foot whips. Chameleon is my favorite brand, but we all know that Alibaba sells them for a tenth of the price. They may not last as long, but they still work. They're still telescoping whips. I don't really care for anything more than 25 feet because then you have to guy it. Like there's a great antenna, 34-foot telescoping whip from Alpha. I've got one, but you have to guy it. And, that just takes more time and you have to carry more stuff. So I stick to antennas that can use a 25 or 17-foot whip. I love mirror mounts, also known as CB mounts, truckers mounts, whatever you want to call them. They're great because not only do they have a coupler for that telescoping whip, but you can attach it to a tripod, or you can attach it to a post, whatever you want. It's there. And so it's very, very convenient. So I like those. I use those in all my antennas. What do you think this is? It's called an RF choke, current balun. ABC. Always be choking. Please don't operate your antenna without an RF choke. You don't, a coax, everyone thinks a coax has 2 conductors. It has 3. It has the inner conductor, it has the inside of the shield, and it has the outside of the shield, and that's where the common mode current likes to run back down the line, creating common mode current and RFI in the shack and all these other nasty things. It's like another radial to your quarter wave antenna or another counterpoise wire. Please don't do that. Always be choking, okay? ABC. Okay, and my favorite kind, yeah, I know you can buy those beads and if you're going to buy beads, put at least 7 on your coax. Anything less than 7 is not going to do much. But a coax wrapped toroid, such as this, Mix 31, will give you 4 times the attenuation that 7 or 8 beads will give you. So I prefer these kinds of chokes, not those beads. I know the beads are convenient, but they don't work anywhere near as well as something like this, where you have about 13 turns around a Mix 31 toroid. Okay, so I talk about mounts, a lot of lightweight tripods. There's a whole bunch on Amazon you can buy for $30, $40, very lightweight. They pack up really small. They fit in a backpack if you want to do that. I do that. Or sometimes I like to use a PVC spike, and I use furniture grade because it has thicker walls. You can use irrigation, whatever. But some of my antennas, I show you how to build them and mount them with this and put a coupler on top for the whip. So you can do that as well. What else? Well, if it's not a quarter wave antenna, you got to have ununs and balance. Some people call them transformers, same thing. Ununs and balance, right? Unun is for an unbalanced antenna fed by an unbalanced feed line, coax, unbalanced, unbalanced. Balun is for a balanced antenna, like a dipole, where you have equal currents on both sides of the feed point. That's called a balanced antenna, fed by an unbalanced coax feed line. So that's called a balun. I like to use 4-to-1, 4-to-1 balun, unbalun, 9-to-1, one of my antennas, the one that I'm going to talk about tonight, the new one that isn't introduced yet. You can use, I also have antennas for end-fed. One of my favorite 49-to-1 transformers, unun, same thing, is on eBay by a guy made in Tennessee, 10 tennis. They got about a 0.96 dB insertion loss, so you lose about 20% right off the top. But, you know, if you're willing to do that, you can use a 49-to-1. My preference, however, is this very thick, double-sized 2-inch toroid from my antennas. It's a 56-to-1. It's got 3 times the volume of this. And instead of being 0.96 dB insertion loss, which gives you about 80% matching efficiency, this only is about a 0.24. So you get about a 91% matching efficiency. So you lose a far less power inside of your 56-to-1. And this is what I have here at home on my postage stamp. And I have an end-fed half-wave in my backyard sloper. And I've worked the world with it. And I love it. I'm very happy. It's about 90%. The antenna is about 90% efficient. But anyway, so ununs and balance if it's not a quarter wave, because you don't need one on that. Silicon coated wire. Why deal with a rat's nest? Yeah, you can use speaker wire. That's fine too. But I love silicon coated wire because you can use it over and over again and it doesn't tangle. And I tangle wires very easily, especially in the field. So I love some bright colored silicon coated wire. You can buy on Amazon relatively inexpensively. And because it is bright colored, people will see it. You don't want people walking into your antennas if you're in a park. And that happens sometimes. What else? There are some antennas of mine that require, instead of a conductive segment, a non-conductive segment. Nothing better than weed whacker line. Non-conductive nylon line you throw into your weed whacker that spins around and eats up those weeds. I know I do my own yard work, and so I use that all the time. But I love it, and it's non-conductive, and it works really well. And we'll talk about why I use it in a couple of my antennas. I also love things called Mueller clips, Mueller. They're all over Amazon. I like the 10 amperes. They're relatively small. Some people call them battery terminals. It's the same kind of thing. The nice thing is you can attach your wire to this, and then this in turn can clip on to a whip if you need to do it. It can clip on to the base if you need to do it for radials and such. Also, you can attach weed whacker line to it. And we'll talk about why I do that when I talk about one of my antennas tonight. The other magic little thing that you need to have in your ham radio stuff box, in addition to Mueller clips, are Vago connectors. Well, that's the way Germans, it's a German company, and it's one of these brilliant designs with 2 little orange levers that flip up, and you put your wire in there, and then you flip it down, and you can't pull it apart. It is an amazing way to connect 2 wires together. And when I create band segments, and I'll show you in the Performer how I do it and why I do it, then Vago or Wago, not Wagyu, that's the beef, but Wago connectors are vital. And you can buy them on Amazon for relatively cheap, and I encourage you to consider those. You can put stripped wire, the ends of your wire, strip wire, into those little, into that. You lift the lever up, you put your wire in there, then you clamp the lever down. But after you do that quite a few times, especially in the field, you can kind of, make your ends kind of yucky. So I love wire ferrules. These things are less than a penny a piece. You buy a cripper for 25 bucks, and it crimps this onto that part of the wire, the strip part of the wire. It never comes off. I mean, it is solid. It's probably the best crimping thing I ever saw with wires. And that little thing just fits right in there, and you put the lever down and you can't pull it apart. So wire ferrules. So these are my Tinker toys. All my antennas are composed of these same kind of components, and you probably have most of these already. Most of these probably already exist in your shack box. All right. So I have lots of antennas, and I'm not going to talk about all of them tonight. We don't have that much time, but I will focus on a couple. I like to design quarter wave antennas, half wave antennas, and I'm getting into full wave antennas now, especially because full wave antennas provide you this extra little added benefits of being very quiet, especially in the neighborhood when you want to reduce some of that noise that may come from your solar panels, from your neighbors' appliances, or whatever else is in your neighborhood. So I've got, and I give them all names because I think it's fun, right? I think it's fun. So we're going to talk about the Performer tonight, portable elevated resonant antenna, quarter wave. I have a parasitic and phased array version of that, and each one of these has its own PDF, and they're all on my website, and they're all free. They're all 15 to 20 pages. I think the most complicated one, the phased array for the quarter wave, is about 27 pages because that's a complicated kind of antenna in terms of understanding how it works, but it's really cool. Take a look at that if you're interested. I also have an NVIS. I had a lot of people ask me, especially in ECOMs, can you create an NVIS, which near vertical incident skywave version of the Performer? And so I did by just adding one wire to it. And I'll talk about that tonight as well. So I have quarter wave antennas. I love half wave antennas. I have something called the Dominator for global domination. It's my DX antenna. It gets off at about 18-degree takeoff angle for when the propagation was great a couple of years ago. I was working the world. I was working over the North Pole in a POTA park to POTA parks in Europe from California, park to park with this antenna. I just love it. You put a little director, parasitic array out of it. You get that, you get about a 3-4 dBi gain, and you lower your takeoff angle to 16 degrees. And that's what I use to work park to park to Europe with Europe. I also have something called the Challenger, which is probably my second most popular antenna because it's so easy to set up. It's an off-center fed. This is an end-fed half wave. This is an off-center fed half wave. It also has a parasitic array option as well for extra gain. You may need that. And then probably the newest and the fastest growing antenna is my Marauder. And it was inspired by the Moxon. I love the Moxon antenna. But I decided I wanted to have a multiband version of it, and I wanted it to be vertically polarized with a low angle of radiation. So we'll talk about that briefly tonight. I don't have a lot of time, but I'll stop and I'll get to that. Then I have some future ones coming out. The one that's coming out next is this thruster. It's a triangular loop, bidirectional loop. I took it out at a POTA park yesterday. I'll show you the results. You can also make it a parasitic array, which I used at the POTA park yesterday. Bank conditions were horrible, but I was making contacts all over the North America. And also I did some RBN testing, which got me into Europe. So I was pretty pleased on 20 meters. So that's pretty cool. I've always loved the half square antenna. That's going to come out probably sometime this fall. That is a full wave, relatively low angle antenna, and that's going to come out, later on this year probably. And then also maybe in the fall, I have this compact inverted V I call the Nether for 80, 60, 40, 30, and 20 meters because the low bands deserve attention, especially as we're going into the solar minimum. So if you're interested in this kind of stuff, and you want to get inspired to maybe build your first antenna, or if you built a lot of antennas and want to build another different kind of antenna, get on my Antenna Geeks list, kj6er.net. You can sign up right there on my website. Okay, I do want to talk about, as we get into the Performer, I do want to talk about some of the, I call it high-level antenna fundamentals. I talk a lot about radiation efficiency. Not everyone fully appreciates that, but I do want to talk about that, and I promise I'll keep it high level, right? I can be a real geek and go down 2 or 3 levels, but I don't want to do that. I want to keep it high level because I want to get the message across. I want to inspire you. I want you to think about this. So let's talk about a resonant antenna. So those of you who have took your exam, this was on the exam. If you haven't taken your exam, you better know this because this is going to be on the exam. This equation Z is equal to R plus JX. What the heck does that even mean? Well, Z is just the letter for impedance, right? R is real resistance. J is the square root of -1. Forget it. Don't worry about that. X means reactance. What happens when you have a resonant antenna? I'm sure you guys and gals know this. At least those of you that passed your exam do. When you have a resonant antenna, your reactance goes to 0 or really close to it. Basically, your capacitance offsets your inductance. And so you have a very small, if not infinitesimal, 0 ohms of reactance, which is good because that means you have impedance Z equal to just R because X is 0, right? So Z equals R. So when you have a resonant antenna, which is all I design and all I use, this is what I use. Z equals real resistance. And what does real resistance mean? If you've got your ICOM 7300 and you've got some really good coax and it's feeding this antenna structure that is resonant, what does it see? It's real simple at a high level. It's real simple. It sees 2 resistors in series to ground. That's it. That's a resonant antenna. 2 resistors in series to ground. Now, just like everything else in life, there are good resistors and there are bad resistors. There are good people and there are less good people. There's yin and there's yang, et cetera, et cetera. Well, no different in ham radio. You have a good resistor called radiation resistance. Now, radiation resistance is dependent upon, you don't have a lot of control based on the kind of antenna you're using. It's configured into the type of antenna it is. For example, at its current maxima, at its feed point, a quarter wave antenna is about 37, 38 ohms or thereabouts. It fluctuates. That's the radiation resistance. That's the resistance that the antenna uses to radiate electromagnetic waves in all directions. That's productive energy. That's your friend. We love that resistor. Like a dipole, for example, the current maxima is at the feed point in the middle. That's about double that, about 70 ohms, right? So that's your good resistor. But like I said, just like everything else in life, there's a yin and there's a yang. In this case, the bad resistor is called loss resistance. Loss resistance. Loss resistance is anything that potential radiation heats up in and around your antenna structure. A little bit in, right? It's going to heat up some insulators and loading elements. You want to minimize using as many of those as possible. And so you have a little control over that. But where you have the most control and where you lose the most potential radiated energy is in the ground. In the ground. Ground losses and ground absorption in the near field. That is wasted energy. That is your bad resistor. So, why do I talk about these 2 resistors? Because these, after a page full of calculations, it comes down to a very simple equation to measure radiation efficiency. Radiation efficiency, and this is the Greek letter eta, it's always shown in a percentage, is the good resistor over the sum of the good plus a bad resistor. That's it. That's radiation efficiency. It's not complicated. Now, to derive that equation, it's got a few steps, but we don't need to know that. This is all you need to know. Radiation resistance over the sum of radiation plus loss resistance. So just looking at this equation, to maximize your radiation efficiency, eta, what do you want to do? You want to minimize your loss resistance. That's simple. It sounds simple. A lot of people don't even do that. They don't think about it. They're heating up ants in the ground, let me tell you, and we'll talk about that in just a moment. So the goal is to minimize your lost resistance. So when I was doing my research back in 2020, when I was trying to design my own antenna, I started finding out about these brilliant antenna scientists, RF engineers. One of my heroes is John Oppenheimer. John Oppenheimer, about 10 to 15 years ago, actually put together a very detailed analysis, and you can look at it online, vertical antenna ground radial loss study. He wanted to know what the bad resistor, the loss resistance would be for a certain number of radials on a quarter wave antenna that you just lay on the ground. Not buried radials. Buried radials are good. Surface radials. He wanted to know, what is the bad resistor? What is the loss resistance for radials laying on the ground? Because I look around and I see a lot of guys just put up their quarter wave antenna. It's about 6 to 12 inches above the ground, the feed point. Then they just dump out 8 radials and lay it on the ground. They go, look, I got an SWR of 1.1. Wow, this is going to be a fantastic antenna. Well, a dummy load has a perfect SWR, and it's a horrible antenna. Don't use SWR as an antenna performance metric. It is not. It is far more important and more related to your coax than it is to your antenna. But that's a whole nother subject. So he wanted to figure out the loss resistance, because we could calculate pretty much through a lot of antenna physics what the radiation resistance is for a certain antenna structure. But what is the loss resistance when you throw one of those wires on the ground? Well, he went through this very intense analysis and testing, and he came up with this brilliant output, which seemed to corroborate with a lot of the studies that were done previously, and also what's buried deep inside the ARRL antenna book. And he publicized this, and it turned out that a lot of people began to wake up to this quote unquote new concept of getting your radials off the ground. Is this a new concept? No. This was done back in the 1930s when Bell Labs told AM radio stations to bury 120 radials in the dirt. Well, a lot of the smaller stations couldn't afford to do that. So a lot of these smart physicists back in the late 30s said, wait a minute, if you elevate radials, you don't have to use as many. And we'll talk about that in just a moment. So let's say you're Rob Fenn. And there's Rob. He goes out into the Baylands with his quarter wave antenna. And he says, Greg, I've got this great antenna. It's got 2 radials on it. And it's omnidirectional. I got a 1.1 SWR. It's fantastic. And I say, all right, you've got 2 radials laying on the ground. That's 79 ohms loss resistance. And Rob goes, 79 ohms? That's nothing. 79 ohms, that's tiny. That's less than 100, right? Yeah, that's right, Rob. It is less than 100. Let's plug it in the equation, Rob. What do you get? Well, the numerator for a quarter wave antenna, let's say it's around 37 ohms. 37 over 37 plus 79 equals what? 32%. So Rob says, wait a minute. Are you telling me that if I'm fortunate enough to apply 100 watts at the feed point to my ground-mounted quarter wave antenna with 2 radials on the ground, I'm only going to radiate about 32 watts? Yeah, that's it. You're only radiating 32 watts. I don't care if you got a 1.0 SWR. You're radiating 32 watts, Rob. And then you get Steve over here, and Steve says, I don't do what Rob does. I've got 8 radials. Well, that's 42 ohms. Let's start plugging all these things into the equation. What do we get? 4 radials on the ground, 1 at each compass point, 37% efficient, 37 watts radiated. 8 radials, 47% efficient, 47 watts radiated. 64 radials, which no one's going to do for portable ops, 83%. That's getting respectable, but it takes at least 86 surface radials laying on the ground to get you 90% efficiency, radiation efficiency. So what if I asked you, Rob, would you rather lay down 86 radials on the ground to get 90% efficiency, or would you rather just elevate 2? I think I know the answer. You're going to elevate 2. But there's Steve over there. He's got his 8 radials on the ground, putting out 47 watts. And here's Greg over here with his performer antenna, just 2 elevated radials. I'm running 90% efficient. I'm putting out 90 watts. He's putting out about half that. I got a 3 dB advantage. And we're both running 100 watts into our antennas. That's why you elevate radials. Radiation efficiency. When I learned this, my eyes opened and I said, okay, everything I do, every antenna that I use for myself and design and share and everything else has to have high radiation efficiency, because commercial guys don't talk about this stuff. In fact, what I found out is if you look at those antennas and those radiation efficiencies, let's say 2 surface radials, we just saw 32%, 4, 37%, 8, 47%, 16, 57%. What size power amplifier would Steve need if he was running 8 radials on the ground to match my performer that's running just 2 elevated radials? Well, would it be 30, 40, 50 watt amplifier? No, because you got the same low radiation efficiency. As you increase your power, it's still being applied to all the watts in there. And plus, if you use good coax, you don't lose too much during your coax, but you still have to deal with all the radiation inefficiencies in your antenna. So if you work through the math, and I've got a whole antenna primer too, which does this. So if you're interested in this kind of geeky stuff, antenna system efficiency from my antennas primer too, it basically takes you from the transceiver down the coax, into SWR termination, into the antenna, looking at antenna gain, which is directivity plus radiation efficiency. It shows you where all your watts are lost along the way before it gets to the antenna. And then at the antenna, it looks at directivity and radiation efficiency to tell you how much you're actually radiating. Well, the performer, which we'll talk about in just a moment, with 2 elevated radials opposite each other, is 90% efficient. And effective radiated power, it's a term that you'll learn more about. If you really want to get into it, go into my antenna primers too. I radiate about 76.4 watts after it goes through 50 feet of LMR 400 with an SWR of 1.5 to 1. So I'm looking at 100 watts from my ICOM 7300 through 50 feet of LMR 400, which is good coax. That's good 10 millimeter, typically 10 millimeter coax, in an SWR of 1.5. I radiate 76 watts in my omnidirectional version. They're only radiating 39 watts. 39 watts. So he would need a 194 watt amplifier with his 8 radials on the ground to match my performer with 2 elevated radials. And then I show you how you can then put your 2 radials 90 degrees apart for some modest directivity. But by doing so, you can also, your effective radiated power goes up to 95 watts. So basically you put in 100, it goes through without an ALC foldback, it goes through your coax, SWR of 1.5, not perfect, SWR of 1.5, some loss in your LMR 400, you can radiate 94 watts. He would need a 40 watt amplifier. Bottom line is, watts are expensive. Don't waste them heating up ants there in Palo Alto. It's really, really important. Now I'm going to get into one more study, and then I'll take a little pause for some questions, but I'm looking at the clock, so I want to make sure we get done by 8:30. One other study I wanted to bring to your attention, because I think it's really important. There's another one of my heroes, Rudy Severance. Rudy put together this landmark study back in 2010, but he did a lot of research in the 90s and 2000s, wrote a lot of articles for QEX and QST. He said, all right, I'm going to go out to this calibrated RF test range field, but it was a calibrated RF test range. And I'm going to take my HP 8753 series VNA, which cost about 50 grand. I know, not these little $80 VNAs you can buy on Amazon, but a real professional HP high accuracy VNA. And he says, I'm going to put up a 40-meter quarter wave antenna with 4 radials laying on the ground. And I'm going to use my VNA about 1.8 wavelengths away. I believe that's what it was. Yeah, 1.8 wavelengths away. So about 250 feet. And I'm going to measure the signal that I put into the structure there and then 1.8 wavelengths away. And what he did is he put 4 radials on the ground, and whatever he measured on his VNA, he normalized that to a 0 dB point. So if you look at this chart, this is dB. Now, dB is not an absolute measurement. It's a relative measurement. It's comparing one thing to another. So he said, okay, here's my gain improvement. Here's the number of radials on the ground. 0 dB is going to be 4 radials, whatever that number was. And he did this over 3 different days, and he ran the same experiment to verify its results. So it's highly regarded. So look it up if you're interested. And he found, to really no one's surprise, You go from 4 radials to 8 radials on the ground, 16 to 32, all the way to 64. He got a 6 dB improvement, almost 5.8 dB improvement with 64 radials laying on the ground. So you would expect that, right? Because the more radials you put on the ground, the less your antenna has to use the ground to go back to the feed point to re-radiate any energy it collects in the radials. So you want to continue and close that RF circuit. So the more radials you put down, the better that circuit is. The less radials, the weaker it is. So he came up with that chart, and everyone says, yeah, that makes sense. We've seen that kind of chart before. Then he said, okay, now I'm going to do something really interesting. I'm going to take those same 4 radials on the ground, and instead of adding more radials on the ground, I'm going to start to elevate these radials. I'm going to elevate them off the ground. And so he came up, same y-axis is 0 to 6 dB, but the x-axis changes. Instead of radials on the ground, numbers of radials on the ground, it's taking those same 4 radials and raising them up over the ground. And what did he find out? Amazingly, on 40 meters, these quarter wave tuned radials, just 6 inches above the ground, he got a 5 dB improvement. In fact, when he raised them up to about 4 feet off the ground, he got a little bit more radiation, 1.8 wavelengths away, than he did with 64 radials on the ground. His conclusion: 4 elevated radials at a height of 4 feet are equivalent to 64 quarter wave radials lying on the ground. Why is that? Why does that happen? Well, let's take a look at a dipole, right? Here's your dipole. And if you're going to take an exam tomorrow, you should know this stuff. So pay attention. And I know who you are because I saw you introduce yourself. What is the current distribution on a dipole? It looks just like this. When it's resonant, what's the voltage distribution? It looks like that. Current and frequency create a standing wave on your dipole, half wave antenna. Here's your feed point right in the middle with both current and voltage 90 degrees out of phase. So where's your current maxima is here, your voltage maxima is there. In fact, let's put that on there. So now what happens when you go out and down your dipole radiator and you have current going down and you have voltage going up? I'll just use Ohm's law. What do you get? Z, because it's purely resistive. Hopefully it's resonant. V over I. R is V over I. Remember that equation in science class? Well, Z equals V over I. But if you have voltage going up and current going down, what's going to happen to your impedance? It's going to go up quickly towards the end. That's why when you have a dipole, it's roughly 70, 72 ohms radiation resistance at the feed point. But as you go down the dipole, what happens? If you feed it down here, let's say an off-center fed, we call it an off-center fed dipole. You feed it down here around 80%. I like 80-20 for off-center fed. You're going to have impedance, instead of being around 70, 72 ohms, it's going to get into the hundreds, 200, 300, 400. So you're going to need a 4 to 9 to 1 unknown. What if you keep going out? N-fed, they call it N-fed. That's about 95% to 5%. 95% of the way down your radiator, you're going to be into the thousands of ohms. Remember, it's just Ohm's law. It's not complicated. It's just Ohm's law. You'll need a 49 to 64 to 1 unknown or transformer. All right, makes sense? All right, let's reconfigure this dipole, make it a bent dipole. Oh, it's beginning to look like a quarter wave antenna now with a radial, isn't it? That's exactly what it is. That's why radials are the other half of your antenna. That's why radials are so important. It's the other half of a bent dipole, if you want to look at it that way. So here's your quarter wave radiator. There's your quarter wave tuned radials. Here's your current distribution. It's just, this one's bent up, so I drew it that way. Where's your current maxima? Right there at the feed point. All right. Now, remember in science class, and I think it was on the exam, I have to go way back in time to remember that, but the equation for capacitance, right? Capacitance. Yeah, you got this dielectric constant in the area of the plates of a capacitor. But what do you have in the denominator? D, the distance between the plates. So capacitance is equal to dielectric times the area of the plates over the distance between the plates. And this is the one I want to talk about, the distance between the plates, right? So What does that tell you? The closer the plates are in your capacitor, the greater the capacitance, right? Because the smaller that number is, the bigger that number is, because they're inversely proportional. The further the plates are from each other, the smaller the capacitance. Again, they're inversely proportional. So now visualize this, my friends. Imagine your quarter wave radial over here is one plate of a capacitor, and the ground is the other plate of the capacitor. Now, we know that capacitive coupling, when your radials are laying on the ground, the distance between those two plates is very, very small. Therefore, your capacitance is very, very big. And capacitive coupling, in this case, is not your friend, because all that potential radiated energy you have in your radial, especially in the first half of your radial, that's see where the current is. If it's laying on the ground, your ground's going to suck it up, and you're going to heat up ants in Palo Alto. You don't want to do that. Thereby, by elevating your radials, you're putting the distance between the plates much, much bigger, decreasing that capacitive coupling. And that's why Oppenheimer discovered that you go up 6 inches, Severance, you go up 6 inches, and oh my gosh, it's dramatically reduced, and you generate far more radiation gain than you would if it was laying on the ground. All right, so I'm going to talk about the performer here, and I know I only have 5 minutes, so I'll make it very quick. So why don't I talk? Yeah, go ahead.
We can give you a little bit more time, but I have seen some of the comments coming up on Zoom, and they're all excited to see how effective you're elevating these radials and the configuration. So why don't we just roll into that?
That's a perfect segue, isn't it? Because I just showed you the slide. Let's talk about the antenna. So let's take all this. Hi, Rob, I can see you on Zoom there. Let's take all of this intelligence that we've just learned and wisdom that we gained from our RF scientist elders, and let's create an antenna. And this is what I created for myself. I didn't call it the performer. I called it, my portable antenna. But this is basically it. And it uses all my Tinker Toys. It's probably, because it's a quarter wave, you got a 50 ohm, typically around a 50 ohm impedance right here at the feed point. So you don't need an unan or a balun. So the performer antenna, portable, elevated, resonant, no tuner required. You have a telescoping whip, a 17-foot whip or 25, 17 is fine to get all the quarter waves. You can get 20 meters all the way up to 6 meters with no coils, nothing else. Very, very efficient. On a mirror mount, ABC, always be choking, right? You don't want this coax to be a third radial. On a tripod or a mirror mount, you put it up about 52 inches. 52 inches, which is about typical height of a tripod or a 40-inch PVC tube with a spike. You elevate 2 radials. You elevate 2 radials either 90 degrees apart for some modest directivity, on average about plus 0.4 dBi gain through the span of the radials, or if you put them opposite each other for omnidirectional gain, you get about minus 0.5 dBi. But when you put them 90 degree, not only do you get a little bit of gain, directivity on your quarter wave antenna between the span of the radials, but I think more importantly, you get 3.1 dB front to back. Now, why is that cool? Well, you can point your 2 radials at 90 degrees towards a desired geographic direction, or you can put the span of those 2 radials at 90 degrees opposite a noise source in the field and knock it down by 3 dB. I do that all the time. Yeah, you get a little bit of directivity. Are you going to notice 1 dB? Sometimes. It depends on conditions, but for the most part, the front to back is the coolest thing about putting these radials like this. And I already figured out through all my modeling and through field testing and years in the field exactly what length of elevated radial you need for each of these bands, so this antenna will resonate at the center of that band. At the center of that band. Because I'm a sideband guy, so I'm typically near the top of the bands, but a CW or digital folks, they're down towards the bottom. So I worked out, so you don't have to do it. It's already figured out for you, and it's all in the PDF. It tells you how to cut all these wires, what length elevated radial you'll need to resonate in the center of the band, and then you can just adjust your whip longer for CW digital or slightly shorter for sideband. It's that simple. And I use fiberglass elevation poles, AKA snow driveway markers, which we don't fortunately have to deal with here in the Bay Area. But I mean, they're cheap on Amazon, or you can get them at any hardware store. They're fiberglass. You don't want to, you want to make sure they're not conductive. My first radiation elevation poles were green tomato stakes. And then I kept getting weird readings when I was testing, and I realized they had a metal core. So don't get those. Just get pure fiberglass if you can. And I figured out you need about 43 inches for 6 meters. You need about 80 inches for 10 meters, all the way on out to 20 meters. And so you can resonate at the center of that band and then adjust your whip. And if you want 40 meters or 30 meters, you just put a little coil there at the base, or I like to put mine up about 2 feet with an elevation pole, aluminum pole in there, so you get it away from the feet point. But if you can't, that's okay. Put it there at the base. And you just add, I put my two 20-meter radials together for a 40-meter radial, and it's just one, but it works just fine. You get a 24-degree radiation takeoff angle, which is really good for regional and continental communications. Perfect for POTA. What did the models show? And this is when I got excited. When you put your radials 90 degrees apart, a right angle, really easy to do in the field. I just take my iPhone and I use the corner of the iPhone to kind of determine my 90-degree angle. You get this beautiful radiation pattern as seen from the side. The purple and the red are the strongest parts of the radiation. And they're between the span of the radials. And you can see that here. And here's your 3 dB front to back right there. Okay. Now, this is the antenna that happened to win the award in the QST antenna design. You can run it on a tripod. They liked it on a PVC tube. I use, again, furniture grade, but you can use whatever you have on hand. Most of us have irrigation pipe in our garage anyway. Performer, portable, elevated, resonant, computer modeled, and then also designed to be lightweight, easy to deploy. It met all my criteria when I put the antenna design together. Here it is in my backyard, my antenna proving ground on a very lightweight, and very portable tripod. You can see I use a Mueller clip, and that's where I attach my 2 wires together, my 2 elevated radial wires together. Rob's doing this. And there's your mirror mount, and there's your choke, and there's your chameleon whip in this particular case. And then here's your driveway snow marker, your driveway marker. It happens to be bright orange, which is great for being in the park with lots of other people. And then you'll see this funny little thing right here. Why do I have that? Let's go back to this right here. Let's say you're on 20 meters and you go, oh my gosh, there's a 10-meter sporadic E opening, or 6 meters. I mean, sporadic E is primarily 6, but it also does 10, especially now during the summer doldrums. And you want to go to those other bands. So what do? Well, when I first started, I would unclip the 2 elevated radials from these poles, move the poles in, take off all these segments that you can see here with the Wago connectors, and then re-put them in the ground over here. That took a little bit of time. And then one day I was on an airplane, had a nice glass of Zinfandel, and I had this epiphany. I go, wait a minute, I don't need to do that. I'll just take some weed whacker line, about 3-4 inches, and interrupt the radial line at the band that I want to operate on. So if I'm on 20 meters, you'll see it back here. If I want to operate on 15 meters, I just take that out and I move it up here. So the antenna will see the 6, 10, 12, and 15. It goes, weed whacker line, no conductivity. I stop right there and never sees anything out here. So I said, you can leave the poles right where they are and just move your weed whacker line up in between the span of the radials. So that's what that's showing here. And you can see it right there in that particular picture. Here's my elevated radial. I use orange wire because it's very visible. You can see my weed whacker is already set for 20 meters at the end. Here are my wire ferrules. You can buy them, like I said, for about less than a penny a piece on Amazon. My Wago connectors, Vago connectors, and my crimper. There's the non-conductive segments. And then when I get them all done, I put them in a nice little spool, put them around my hand, put a little Velcro strap on them, take them out to the picnic table. Or if I want to go up into the hills with my 705, I put them on a little kite winder. I take my little Rig Expert, love this thing, my stick, my Byberry multi-tool, and I love this little Chameleon M coil for 40 meters. It works really great, and it's very small. And I put the whole thing in a toiletry bag. you can buy these on Amazon for a couple bucks as well. Really cheap, and it's a great way to see what's inside your little portable carrying bags. I do have a backpack version. I use a slightly smaller diameter PVC tube. I use slightly shorter elevation stakes, 3 foot instead of 4 foot. Doesn't make any difference in this case. I put them all in my ICOM 705 backpack, that little toiletry bag you saw on the previous slide there. And there it is, ready to go up into the hills, up into the San Jose. I like the Santa Teresa Hills, Radio Mountain, I call it. I think the IBM repeaters there, WIBM repeaters there. And by the way, here's a Sporty 40 next to the M coil. This is why I like the M coil. So small, lightweight. It's expensive. It's like $70. But if you can afford it, it's a great little gadget. I recommend it. But the real world is this. You take it out to the field, and this was done at Marshall Cottle Park, Uncle Sam 3473 here in San Jose. And I want you to notice 2 things. I want you to notice that how low and how great the match is on each of the bands. So very low SWR. But most importantly, look how broad banded it is. And let's take a look at this little flashing icon over here. What does that say? Avoid SWR derangement syndrome. You don't need 1.1. It's okay to have 1.5. You're only about 4% mismatch. It's okay. A 1.5 versus a 1.0, not going to make a bunch of difference in the real world. So if you look at these, you can run the entire 20-meter band without having to adjust the whip. 17, 15-meter band, the entire band 1.2 to 1 or better. 12-meter band, very narrow but very flat. 10-meter band, I typically operate down here in sideband, and of course the 6-meter band when there's sporadic E opening. Let me pause there because it is 8:35. And if you want, I can answer some questions right here, or I can get to the next antenna and then wrap things up.
Oh, it sounds like just move on to the next antenna. We'll grab all the questions right at the end. If you're on Zoom, post your questions in the chat, and then we'll grab those.
Excellent. And you'll be the moderator?
Yeah, we'll do it, or Ben will, because he's going to be looking at the chat there.
Attaboy. Okay, great. Okay, so I mentioned earlier how a lot of people, I kept getting a lot of requests for, and I'll go through these more quickly now because I know we're running out of time. They said, I love the Performer, but I want an NVIS version. Can you give me an NVIS antenna? I used to tell them the same thing I used to tell most people. If you want a good NVIS antenna, just low to the ground dipole works great. The problem is you have to cut it exactly to where you want to operate because, right, you want it resonant, so you want to cut it, trim it, and all that sort of thing. And I said, oh, wait a minute. I got something special with the Performer, don't I? Why do we want to do that? Because we want to get into the skip zone. What is the skip zone? This is on one of the exams, so remember this. Ground wave, depending on which band you're on, only goes out so far, maybe 10, 20, 40, 60 miles, depending on your topography. That's ground wave. Right? You've heard people say, oh, yeah, we're ground wave. We're local. Palo Alto to San Jose, ground wave. Very typical. When you have something called sky wave, it refracts. People say reflect, but it really refracts off the F layers, typically. Sometimes the E layer, if you're lucky, sporadic E, but let's say F layers. And your first ionospheric hop is going to be out 500, 2,000 miles, depending on how great the ionosphere, how high it is, the time of year. There's so many variables. It changes dramatically. So you end up with something called a skip zone. So what I wanted to do was come up with an NVIS antenna, which means if you're at 10 megahertz and below NVIS, you go up at a very high angle and you come down pretty much at the same angle because it penetrates the D layer so quickly, it can bounce off the F layer and come down relatively locally. Emergency communications does this. And so I said, okay, let's do that. But then I said, you know what? We can play around with the upper bands too. It won't come down. It refracts at a bigger angle. But if the conditions are right, you can get inside your skip zone. And so what I said is, okay, here's your Performer, right? We just saw this. This is your Performer, everything to the right. You add one extra wire to it. And what does this look like? If you go like this is your radiator on a very short whip, 34 inches. That's why this is very popular at HOAs, because they're very low profile. 34-inch whip, and then you have the other half of the so-called dipole in this case, or I put the 2 Performer elevated radials together to the other elevation stake, and you basically have a low to the ground tunable dipole. Tunable dipole with band linked segments on both sides, the radiator and also the radial. And you can use these weed whacker to put in between the bands that you want. So you don't have to move the elevation poles. You can just move these two in between the bands you want here and put it there, and you can operate on that band. It works really, really well. And what does it produce? A big, beautiful bubble of radiation going up at 86 degrees on average across the 6 bands. And it uses the ground as a reflector. So it's dependent on the ground, but if you have reasonable fertile ground here in Silicon Valley, you get a plus 2.5 dBi gain at an 86-degree angle, straight up, producing this big, beautiful bubble. I then have a parasitic array where you can use 2 performers to give you basically double the radiation, and is very directional of a single performer. And this is what the radiation pattern looks like, commonly called, it's similar to a cardioid, unidirectional antenna with a 2.4 dBi and an 8.2 dB front to back. It's pretty darn good. I also have some half-wave antennas. I mentioned the off-center fed and the end fed, using a 4-to-1 on the off-center fed and a 49-to-1. Or if you want more efficiency, you can get a better 4-to-1 unun and a higher efficient 56-to-1 unun. And so those are my half-wave antennas. Those are the Challengers, very, very popular, because you just put one little counterpoise and you can put it on the ground because there's very little current in your counterpoise at that point in your antenna. And here you go, you get 2 very flat radiation patterns. This is the off-center fed, even flatter, lower angular radiation. Here's your end-fed telescoping whip called the Dominator. I love the Moxon antenna. I thought it's one of my favorite antennas put out by Moxon in the 1980s. Basically, if you look at it, it is a bent dipole radiator here. And here it is with tubes, and here it is with wires. And behind it is a parasitic reflector, a little bit longer. And you can't really see it on the screen, I bet, but this is a non-conducting insulation between the bent dipole radiator and the parasitic reflector. And I said, I love this antenna, but you got to get it up a half wavelength, and on 20 meters, that can be a little challenging, right? So I came up with what I call the Marauder. And I said, rather than feeding each one of those elements in the middle, let's feed them at the end. So I created with 2 telescoping whips and 2 cross wires. Here is your bent end-fed half-wave radiator. And there is a non-conducting segment, weed whacker line. That's why I use it. So here's your radiator, weed whacker line to isolate it from the bent reflector. So the reflector is here, the radiator is there. Get it? And so you get, it's vertically polarized, 3.4 dBi gain across all the bands. This thing is a monster with 15 dB front to back. I introduced this in March, I believe, and it's becoming one of my fastest downloaded antenna designs. And it produces this big, great directional bubble, not only at low angles, but you see it has some extra radiation up here for some regional communications. So this antenna is very popular for DX, continental, and regional communications. And the one I'll be introducing, which I've been testing at POTA the last month, is called the Thruster. It's a triangular loop using a 4-to-1 balun with a B, because it's a full wave antenna. It's a balanced antenna. No counterpoise, no radials, because it's a full wave antenna. And if you put a reflector triangle behind it, which is what I did, you can get up to 4 dBi gain bidirectional through the center of the loop. And this is what it looks like. Here's the single triangular loop, what it looks like. You can see here's where the balun is. You get a little bit less radiation over there because the balun's there. And then when you put it with a reflector loop behind it, I was just out at the park, US Uncle Sam 3473 yesterday in San Jose. I did some RBN testing on it, and it was a horrific day on the bands, really bad. If you were on yesterday for HF, it was really tough. Fair to good propagation, but I used the RBN network. I used some CW, 20 watts, and look, this is with the loop behind it, the reflector. You can see all that gain going straight across the US, and I was getting 9 to 17 dB of gain at Whiskey 1 November Tango in New Hampshire. He's a really great RBN receiver. And then I also got into Europe. Look at this, 27 dB Golf 4 India, Romeo, November. He has a couple of them, 14 to 27 dB going over the pole with this antenna. It's amazing. Also got into Italy. That's just doing some RBN testing on a bad day in the bands. Okay, so I'm going to wrap up here. I got 1 more minute of stuff. Over the years, people kept saying, Greg, could you build me antennas? Because I don't have the ability, time, or the tools to build my own. So a very nice ham in the Midwest who runs his own technology manufacturing company raised his hand and said, I'll hand make all these antennas and we'll sell them on Etsy. And I said, okay, sure, go for it. So he's done this. He sells all of these antennas and all the links are on my website. If you're ever interested, they're all handmade. He sold over 310 of them with over 75 5-star reviews. So he does a really good job on the antennas. He also does a lot of accessories. He also is now getting into my antennas, but turning them into kits, like a Heath kit. We loved Heath kits when we were kids. He turns them into kits, and he also will do custom designed antennas if you're interested. So it's all on Etsy, and the links for J Systems on Etsy are on my website. So those are all my antennas. If you're interested in these sort of things, get on my Antenna Geek list, kj6er.net. Send me an email if you think of some great questions in the middle of the night, and I'll answer them. And I promise everything I do, all my designs will always be free, and they'll always be available here on my website. So with that, I'm going to stop sharing. I apologize for going 15 minutes over, but
That's okay. It's fascinating stuff.
I'll take live questions.
So we'll take questions in the room and then we'll take them on Zoom. One of the best comments I saw on Zoom so far was from Misha AC6Y. He says, I got to get myself some good Zinfandel based on your cause of your epiphany.
Zinfandel, yeah, right. Yeah, I was flying to see our grand critters down in San Diego, and I was thinking about how can I improve this? And I go, oh yeah, that's Zinfandel. That really makes you creative.
All right, we've got Elliot's up. Go ahead, Elliot.
Hey, I'm Elliot, Kilo 9 Echo Oscar.
Hey,
I've worked you park to park, you and Uncle Oscar park to park before as Alpha Kilo 6 Echo uniforms. My previous.
Oh yeah, I know that call sign.
So I had a question for you, and I apologize if it's a slightly tough one. Which is when you talked a lot about the difference in radiation efficiency between ground-mounted and elevated radials. But my question for you is, as you raise the radials off the ground, it's going to behave more and more like a dipole. And because the sky is broadside to your radials, have you measured, or do you know how much of the extra radiation resistance you're getting off those radials are actually going out towards the horizon? Which is to say, while I know you have measured the radiation angle of those
computer model,
antennas,
I don't measure it. The computer model calculated it. I have to be honest.
Calculated. So my question is, do you have an idea of how much of that radiation resistance that you gain from elevating the radials is actually going in the direction you want?
So let's see if I understand your question. You're saying by elevating the radial, how is it affecting the takeoff angle? I'm not sure I understand the question.
Yes. So to put it into perspective, if you were over a perfect ground, right, or very close to perfect ground, like
which doesn't exist, right?
Right. Then you would see a takeoff angle of just about 0 degrees. And so yeah. So my question is, how much of the extra effective power out that you're getting is actually going towards the horizon, and how does that change the relative efficiency of the performer antenna versus an antenna with ground-mounted radials?
So probably the simplest way to put it, and I'm trying to be pragmatic here, the worse the ground, the more impact elevated radials have. The worse the ground, as measured by conductivity and permittivity, the greater the effect the elevated radials have on the antenna in terms of radiation efficiency. If you were at a beach, a salty beach, like if you're right there at the Baylands where it's really salty and you can put your quarter wave antenna right there in the salt with very high conductivity and permittivity, you probably won't need elevated radials because the ground isn't absorbing. In that particular case, the ground is a wonderful conductor. And so it's not absorbing. And so if you look at for example, a theoretical antenna over perfect ground, you'll see the radiation pattern kind of go straight down to the ground. and basically the ground becomes the other half of the antenna, right? But in real ground, it begins to absorb. So it begins to absorb some of the radiation that's really close to the ground. And so that's why you have this gap between your typical quarter wave antenna with these lobes, because when it's really close to the ground, that's being absorbed by the ground. And that is really what sets your radiation angle. So when you elevate your radials over average ground, which is what most of us have, you have more control over configuring that radiation angle at something, in this case, around 24 degrees. And if you want to begin to mess with the impedance that's at the feed point, what I do, for example, in my design, if you angle the radials down slightly, I said you go, your feed point's at 52 inches and the ends of your radials are about 36 inches. That the computer model told me that I call it the droop angle. I think it's called the droop angle. As you move it closer to the ground, the ends of the radials, you can increase the impedance at the feed point, because typically when you elevate radials, you've got a lower impedance at the feed point. So to raise it closer to 50 ohms, so you don't need a tuner, you can droop them down a little bit. And in my antenna, it's about 5 to 10 degrees, depending on how you set up. And I experimented. You can move the ends of the radials with those Muller clips up and down those elevation poles. And you can also tune the antenna impedance that way as well, because you're literally changing the elevation or the droop angle of the radials, which in turn affects the impedance at the feed point. I'm not sure if that answers your question, but I'm trying to tell you what the ground does relative to the elevated radials and how it affects the feed point impedance and the takeoff angle.
Yeah, not to monopolize too much, but when you actually do move the ends of the radials up and down and adjust that droop angle, is there a simulated or measured difference to the efficiency that you see, which would be an equivalent statement to my original question?
Yeah, so you can't, unfortunately, there's no such thing as a radiation efficiency meter. I wish there was. It'd make life so much easier, but I have to computer model it. So I computer modeled the radials flat at 5 degrees, 10 degrees, 15, et cetera, et cetera. It changes the feed point resistance as you get closer to the ground, it slightly increases the ground loss in the antenna. But because it's relatively high to begin with, you're talking about 92% to about 89% or somewhere in that vicinity. So depending on the ground, by moving the ends of the radials down a little bit, you can actually move the impedance closer to 50 ohms if you're too low, or if you're too high, you can do the same by playing with the radials, going up a little higher, going down a little lower. It has a direct impact because you're adding a little bit of ground loss by moving the radials closer. But remember, in my diagram, the current that's in the radial, the bulk of the current in the radials is in the first third to half. So as long as the first third of the half of the radial is up high, you've got a lot of, that's where the bulk of your radiation efficiency comes from. The other third towards the ends, a little bit less. And so think of it this way, maybe 80, I'm just throwing numbers out just based on some modeling experience, 88% efficiency comes from the first half of the radial. And then you can, depending on where you have the ends, you can tweak that up to 92% if it's higher, or 89% if it's lower. Again, all depending on where you want to get that feed point impedance. It's a modeling game. It's not something you can measure directly with a radiation efficiency meter. I wish there was, but you can model it and play games with it. In the end, we're all amateurs, right? And so if you get two elevated radials up from 52 to 36 inches, you're going to have on average about 90% radiation efficiency. So just think of it that way. If you think too much about it, you'll get deep inside a squirrel hole and you'll never get out. So I try to keep it pretty simple and high level.
Okay, Andy, go ahead with your question.
Okay, now all these figures are beautiful on theoretical estimates, but have you done any physical measurement, like with a drone or a tall stick with a field strength sensor?
Yeah, wouldn't that be cool? Yeah, I have a good friend of mine who, the big problem is California parks don't allow drones. So you'd have to do something elsewhere that isn't an official park. But I have a good friend of mine that was talking about doing exactly what he says, exactly what you said, putting up four drones roughly in each compass point with a collection of sensors and trying to measure exactly what kind of radiation you have at different distances within relatively, that's considered the far field once you're past about a wavelength. So yeah, that would be really cool, Andy. I would love to do that, but no, I've never done that.
Any more questions in the room? We have a bunch on Zoom, so don't feel bad.
You can also write me. If a
Okay.
magic elf appeared and offered you a magical BNC cap that acted as an impossible, oh, I missed that one. Okay, that one just came in. Sounded interesting.
So let's go from the beginning. There were a bunch of the Zoom was unusually active today.
Unusually?
Yeah.
Oh,
So
good.
the first one was, what are your thoughts on Teflon coated wire? That was for me. Personally, I find that Teflon wire is really convenient because it doesn't get tangled in trees or on itself.
As opposed to silicone coated?
Yeah.
I've never used it. It's probably more expensive, isn't it?
It's a little more expensive, but Teflon's pretty cheap these days.
Yeah, it probably is. I've never used it. I love silicone coated wire because it's never tangled for me in the field. I don't put wires in trees, as I told you, because these parks don't let me do that. But I've never had any problems with silicone coated. But if you've got Teflon coated wire, all the better, because it's probably going to be even slippier than silicone.
Yeah, I find the silicone. Gary's going to say his comment on the air.
Okay.
Teflon coated wire has to be silver plated copper. You can't use just copper wire with Teflon.
Silver coated copper. That sounds expensive.
There was another question about silver coated wire, so we'll hang on to that until we get there. The next question was sort of a joke, sort of a question. It was when you were talking about putting down 120 radials on the ground.
Yeah.
The question is, if you had a very large sheet of tinfoil, does that count as infinity radials?
Yeah, I often thought that in fact there was these what do they call the magic carpet? These squares. The problem is yeah, if you've got a big enough piece of aluminum foil that was perfectly flat, and even though it was resting on the ground, but it was big enough and it went out, it doesn't have to go out a quarter wavelength, but let's say close to that, because most of the current is in the first half.
Hi, Greg. If you could just hang on, I'm sorry, 1 second. We have a small internet problem in the room that I'm going to address right now.
Okay. Tell me when to talk.
Okay, we should be back now. I'm sorry, we took an involuntary break.
No worries.
So you were talking about large sheets of tinfoil acting as
Yeah, the
gravity.
short answer is it would be really cool to experiment with a huge piece of aluminum foil, so to speak, that was probably, I would say, at least 6/10 of a wavelength wide on the band that you're operating on. That would be really interesting to experiment with because that would be like almost an infinity number of radials. The closest thing I had to that was a buddy of mine that had a shed with a big metal, I'm not sure what the metal was, but a big metal roof. And the beauty of it was the shed was flat. The roof was flat, I mean, and it was built on a wood shed. And so I said, that could be like an elevated ground plane. So we put up a quarter wave antenna on his big metal roof, which was acting like a bunch of elevated radials, but in one continuous segment, and it worked really, really well. So I would have to assume, and I've never tried it, even though it's on the ground and there's some capacitive coupling, if you've got it big enough and wide enough, then it could work. It'd be an interesting experiment. I'd love to try it. I've never done it.
So around here we have something that's pretty close to that, which is called a salt marsh.
Yeah, that's what I was thinking of.
And that's
exactly.
where we do our. That's where Para does our field day. So
Yes,
see you there next year.
Yeah. No, I was gonna. That's why I mentioned that in the presentation. That Baylands right there, that salt marsh, that's basically, you don't need elevated radials there. Just stick your quarter wave in the ground and you're set.
And then the next question. Next question you actually answered in their presentation directly.
Okay.
So I'm going to skip that.
Okay.
Then there are two more. One is is silver plated wire worth it for radiators or radials in any common conditions?
I've never used it, so I can't speak from experience. I know silver is probably the best conductor. And I have seen people talk about there are benefits to using silver coated wire. But I then saw an analysis just recently, as a matter of fact, where he was comparing military grade silver coated wire to speaker wire. And he looked at everything from velocity factor and conductivity, et cetera, et cetera. And he says, yeah, the silver coated wire is by far the best, but it's such a small difference ultimately that most hams probably wouldn't notice any difference at all. But if you've got it and you want to use it, why not? It's kind of like that Teflon wire. Silver is the best conductor, but is it worth paying a lot of money to get that if you don't already have it? Probably not, in my opinion.
And then the last one was, if a magic elf appeared and offered
Yeah, I saw that one.
a magical, I'm just going to read it so the people in the room can see it.
Yeah.
And offered you a magical BNC cap that acted as a perfect 100% efficient isotropic radiator on all frequencies, with the caveat that it's the only antenna you could use as long as you own it. Would you take it?
How high off the ground could I use it?
It doesn't seem to be stated in the question. So let's say you could put it as high as you want.
Yeah. Yeah, why not? Why not? Why not? It would be kind of fun to experiment with it. Isotropic antenna is a theoretical mathematical antenna only. It does not exist. But if a magic elf said he had one and he offered it to me free of charge, I'd take it and I'd play with it and I'd experiment and I'd turn it into a really cool antenna. But we all know that that's just fantasy.
I guess another way to ask the question, so it says it's the only one that you can use as long as you owned it. So another way to ask the question is, how long would you choose to own that antenna?
I've never had that question before. To be honest, I'll be very honest with you. I love the challenge of taking imperfect components and turning it into a pretty darn good antenna. So I would be bored with it, I think. I think that the antenna would be so darn good and I couldn't really change it or reconfigure it or probably throw it in my backpack effectively. So I probably would turn the magic elf down. I would ask the elf for something else, but I wouldn't ask for an isotropic antenna. I got other priorities in life.
Is that it, Ben?
Yeah,
Good question.
I guess any final questions in the room? Okay, you got one more.
Okay, go. Don't forget my email. You can use my email if you think of a question as you drive home.
Not exactly a question, but an announcement. The San Mateo Radio Club is going to be building your performer antenna next Sunday. So
very cool.
If anyone has any questions about that, let me know.
That is way cool.
Awesome.
That's a San Mateo Club?
Yeah. Yes, he said the San Mateo Club.
Yeah. So I've had quite a few clubs around the country have antenna builds with the performer, the Challenger off-center fed half wave, the Dominator. They even did the performer parasitic array for field day. And I get these great reports back and it makes me feel really good that because they got a bunch of the members together and they all built it together so they could build up their own confidence, that they can design and build their own antenna and then use it effectively on field day. That's really cool. I'm so happy to hear that.
All right, Greg, with the combination of the people in the room and that we're attending Zoom, I think I had somewhere around 65 people tonight listening to you.
Wow, good.
And
Great.
wow, very fascinating. Thanks again.
My
And
pleasure.
I got some work to do.
And hey, every Friday, I'm at Uncle Sam 3473. So you folks of the Baylands who have worked me on your QRP radios, let's do it again next week. I'll be there. And I love working park to park. Well, no, it's not officially a park, but still fun. Portable to portable. Ground
All
wave.
right. Thank you.
All
You
right.
feel free to stick around if you like. We're going to move on here.